Hello everyone, welcome to the course on signal processing. This is lecture 2 and in this lecture we will see the introduction of signal processing. So first of all we will see what is signal, after that we will see what is system and how a system basically convert an input signal to an output signal, and what is the role of signal processing which is applied to the raw signal as an input. So in this lecture we will see the digital signal processing which is going to apply on various type of input signals like image signal, like speech signal, like text. So we will be proceeding with the definition for signals and systems. So basically I am going to start with the signals and system first. First we will be having the introduction for signals and systems. We will move to the properties of systems, and after that we will start with the LTI system. So signal basically plays a very important role in our life. A signal can be a function of time, distance, position, temperature, pressure, etc. It can be represented by some variable of interest associated with it. For example, in an electrical system we have the signals, either the current signal or the voltage signals. In a mechanical system, the signals are associated are known as the force, speed, torque, etc. In addition to these, some examples of signals that we encountered in our daily lives are the speech signals, the music, pictures, the video signals. So signal is basically, it is a physical quantity which contains some information. So a signal carrier information, and the objective of signal processing is to extract the information from the raw data. So this is the signals. Now what are systems? Systems are basically, system is a interconnection of blocks or components which convert one form of signal into another form. For example, let us say we have some raw signals, and with the help of some filters we can process that information, and the information will be converted to some meaningful information. Likewise in the communication receivers at the detection side. So the function of a system is to process a given input sequence to generate an output sequence or the signal. Next is the processing. What is processing? So why the processing is required? So signal processing basically is a method of extracting the information from the signals, means these are the raw signals, these are the input signals, which in turn depend on the type of signals and the nature of information it carries. What type of information the signal is carries? Thus the signal processing is concerned with the representing signal in a mathematical term and extracting the information by carrying out the algorithm operation on the signals. So we will be seeing what type of processing we are going to apply on these raw signals. Now we have the advantages. What are the advantages of the digital signal processing, DSP, over the analog signal processing, ASP? So the digital circuits do not depend upon the precise value of digital signals for their operation. Digital circuits are less sensitive to the change in the component values, although in the ASP when we have the capacitors, we have the inductors, resistors, so they are very sensitive to the variation. They are also, these digital circuits are also less sensitive to the variation in temperature, aging and other external parameters. So this is again a very important advantage of using DSP, digital signal processing, over the analog signal processing. Digital processing is stable, reliable, flexible, predictable and repeatable, whereas with the help of digital processors, the signals and the system coefficients are represented as a binary words, we will see later on while we are designing the filters, then we have the filter coefficients. So, with the help of these processors we can have the system coefficients. This enables to choose an accuracy by increasing or decreasing the number of bits in a binary word. Digital implementation of a system allows easy adjustment of the processor characteristics during the processing. Also, when we have designed, when we assign some coefficient to the system, so with the help of the storage of digital data is very easy. So, to storing these digital data, these coefficient value, it is quite easy. Although there are numerous advantages further for the DSP over the ASP. Now, we have some application areas of digital signal processing. So, some selected application of digital signal processing that are often encountered in the daily life are listed below. So, let us say in the telecommunication. So, how this DSP is being used in the telecommunication. So, for the echo cancellation means when you are talking, so what happens, the same voice interfere with the original signal, that creates a echo. So, with the help of this digital signal processing, echo cancellation can be performed on the signals. Next is the military applications. So, in the military applications we have the radar signal processing. So, we are already aware that radar is a very important device used in the military. So, the processing is performed on the radar signals. In the consumer electronics we have the digital audio oblique televisions. So, in television also, in the digital signals the processing is applied, which is the digital signal processing. We have the image processing. So, image representation, compression and the enhancement part, that is also performed with the help of DSP. We have some medicine applications which include medical diagnostic instruments, and the images are generated with the help of these instruments, and the processing also applied on these signals. After that, some applications are the filtering. So, removal of the unwanted signal or removal of the unwanted background noise from the raw signal, it is also called as a signal filtering. So, apart from these applications we have other applications also. Now we will see what are the classifications of signals. So, first important classification of signal is the continuous time signal and the discrete time signals. So, this is a classification based on the time scale. If we will see, the signal is having two attributes, one is the amplitude, one is the time. So, based on this time scale, the signal can be classified as continuous time signal and discrete time signal, whereas based on the amplitude we have the analog signal and digital signal, analog and digital, that is based on the amplitude, whereas continuous time and discrete time, they both depend upon the time axis. So, on the basis of this time or basically the amplitude, let me classify the signals. So, signals are classified as, first important thing here is the deterministic and the random signals, or it is called as deterministic and non-deterministic signals. Second classification, which is based on the periodicity, whether the signal is periodic or aperiodic. Next classification is based on the even and odd part, whether the signal is said to be an even signal or a odd signal. We will see the causal and the non-causal signals, and finally we have the energy and the power signals. So, first we will start with the deterministic and the random signals. So, as the name suggests, deterministic signals means the signals which can be mathematically represented. So their values are known. So those type of signals are known as deterministic signals. Whereas if a signal is not represented mathematically, or if we are not able to predict the value of the signal, predict the amplitude of the signal, those type of signals are called as non-deterministic. For example, if we have a sine function y equals to sine t. So at a particular time t, we have the output, and the output is predicted. The output can be determined. So this type of signal which is mathematically represented is called as deterministic. Whereas if we consider the example of a thermal noise which generate in the electrical circuit, so the value of the amplitude of the thermal noise is not predicted, it is not be able to determined. So the thermal noise signal is known as a non-deterministic signal, or this non-deterministic signal is also known as random signal. So after this we have the second classification, which is based on the periodicity of the signal. So how a signal, when a signal is said to be periodic? So a signal is said to be periodic if it repeats itself after a fundamental time period capital T. So if x of t plus capital T is same as xt, then the signal is said to be periodic. Otherwise the signal is said to be aperiodic. Also the condition here is that time t must be from minus infinite to infinite, means the signal must exist in both the sides, in the negative half as well as in the positive half. So the capital T, it is the smallest value which satisfy this particular equation. So this is known as a fundamental time period, and based on this we are denoting this as T naught. We will denote this fundamental time period T as T naught, and based on this value we can also calculate the fundamental frequency. So a periodic signal has a definite pattern that repeats over and over, means it will repeat. Like say we have example of a sine wave, sine 2 pi t, let us say. So what happened? The signal repeat after a fundamental frequency of, let us say, 2 pi. So it repeats itself. Next classification is the even and odd signal. So when a signal is said to be even, if it follows xt equals to x of minus t. For example, if we have a cosine signal cos of t, so if we put t equals to minus t in this particular signal, then we are getting a same signal, means if x of minus t equals to xt, then the signal is said to be an even signal. Otherwise we have the condition is x of minus t equals to minus of xt, or for a discrete time signal we have x of minus n equals to minus of xn. So these are the condition for the signal to be odd. And we are already aware, let us say if we take an example of sine t, y equal to sine t. So we can clearly see if we will put t equals to minus t, we are getting minus of sine t. So the signal cos is something like this. So these are the mirror image about the vertical axis, whereas if we will see sine function, so sine function is something like this. So it is not mirror image. So we can choose the even and odd signal by seeing the signal itself, or mathematically we can check with the help of these two conditions whether the signal is even or odd. Next classification is the causal and non-causal signals. So a continuous time signal is said to be a causal if its amplitude is 0 for negative value of time. means if xt equal to 0 for all t less than 0. So, those type of signals are called as the causal signals, whereas if it is not following this, it is called as non-causal. Now, the anti-causal is bit different. Anti-causal is just opposite of the causal, means x of t equals to 0 for all t greater than 0. This is called as anti-causal. So, we have causal, we have non-causal, and we have anti-causal. So, this is again the classification. Next is the energy and power signals. So, when a signal is said to be an energy signal or a power signal. So, first of all, we will calculate, we have the mathematical formula to calculate the energy of the signal. How we can calculate? E equals to limit t approaches infinity integration minus t to t mod of xt square dt, and since it is the energy, so the unit will be definitely joules, and the power can be calculated by using this particular function, this particular formula. Now, if we will replace this value by E, so what we are getting here is that P equals to limit t approaches infinity E by 2t. I am first talking about the continuous time signal. So, let us say if the signal is periodic with the fundamental time period t, so we are getting a relationship between energy and power, which is P equals to limit t approaches infinity E by 2t. Now, first thing is when a signal is said to be energy signal. So, a signal is said to be energy signal if energy is finite. If energy is finite, and for those type of signal, the power is finite by some infinite value, we are getting 0. For the power signal, the energy is infinite, whereas the power is finite. We can see if energy is also infinite and we have a infinite by infinite term, definitely with the help of L'Hospital rule, the power will be finite. So, this is energy and power. Now, the third category is neither energy nor power. So, neither energy nor power means when energy and power both are coming, which is equals to infinite. So, these type of signals are known as neither energy nor power. By seeing also the signals which are basically converging, means as t approaches infinity, if the signal amplitude is going in a downward direction, then those type of signal is basically the energy signal. Whereas we have one more point that some periodic signals are also the power signals, and the signals which are unbounded, means which are going in this particular direction, means as t approaches infinity, their values are also approaching towards infinity. So, those type of signals are called as power signal, neither energy nor power. So, we have this classification, energy, power, and neither energy nor power. So, after this we will see the classification of systems, how the systems are classified. So, the systems are broadly classified as we have seen on the basis of the continuous and the discrete time, and both the continuous and the discrete time systems are further classified into the following types, which is the first important thing is the static and dynamic. As the name suggests, static means if it is not depending upon the, if let us say the output, present output is depending upon the present input, then it is called a static system. We will see the definitions. Next classification is the linear, non-linear. We have the time variant and invariant, causal and non-causal systems, stable and unstable systems, and finally the invertible and non-invertible systems. So, first we are going to start with the static and dynamic. As the name suggests, the output of the static system at any specific time depend upon the input at the particular time. Means if the present output is depending upon the present input, then the system is said to be static. And if let us say we can take some example, let us say yt equals to x of t plus 2, means at t equal to 0, the input is taking a value at x of 2, means we can say that the present output at t equal to 0 is depending upon the value which is x of 2. So, this system is called as dynamic system, or the system is having a memory. Dynamic systems are having a memory, whereas static system does not require the memory. We can have some example of static also. Let us say yt equals to, let us say, x square t. So, we can see that t equal to 0, if we are taking the output, then the input is also at the same time. So, this is called as static systems. Next is the linear and non-linear system. So, when a system is said to be linear, it is very important, because we are going to start with the LTI, linear time invariant. So, we must understand that how a system is linear and non-linear. So, a system is said to be linear if it follows the principle of superposition. Now, what is the principle of superposition? If principle of superposition consists of two things, one is homogeneity and additivity. Homogeneity and additivity. So, first, what is homogeneity? Means if the input x is multiplied by a factor by constant a, then output should also be multiplied by the same factor a, that is called as homogeneity. And what is additivity? Additivity means if corresponding to input x1 we have the output y1, so corresponding to x2 we have the output y2, so x1 plus x2 will give rise to y1 plus y2, that is called as additivity. So, first is we are going to use this superposition theorem, principle of superposition for the to check whether the system is linear or non-linear. So, how we are going to check? First step, if x1 t is a signal and it is multiplied by some constant a1, we have some x2 signal which is again multiplied by constant a2, then after adding we are getting a signal which is a1 times x1 plus a2 times x2, and after that we are applying the system. We are applying the system onto this signal. This is step 1. Now, step 2. What is step 2? Let us say we have the signal x1 and x2 and we are going to apply system individually on these inputs. So, we have applied the system. Now, we will use the homogeneity which is a1 and a2, means the response, the output is multiplied by the factor a1 and a2. So, we are getting a1 times system on x1 plus a2 times system on x2. So, if both the equations are same, if both the equations are equal, then we can say the system is said to be linear. And if both the systems are different, both the equations are different, let us say equation 1 and equation 2, then we can say that the system is non-linear. Next is the time variant and the time invariant. This is again very important while we are studying the LTI systems. So, a time invariant system is a one whose input output relationship does not vary with respect to time. Means if the time shift in the input signal results in the same time shift in the output signal, right. So, then it is called as a time invariant system, and otherwise it is called as time variant. So, the time invariant systems are also called as the fixed systems. So, we have the method, we will see later on in our next lectures that how we are going to check the time variancy of the system. Next we have the causal and non-causal. So, as we have seen that the causal signals are, or the causal systems are those whose present output depending upon the present or past values of the input. Those type of systems are called as causal or non-anticipatory system. Whereas, if the output is also depending upon the future value, then those types of systems are called as non-causal systems, and non-causal systems are physically non-realizable. Means throughout the signal processing subject we are going to see the causal systems, mostly the causal systems, because they are physically realizable, means we can represent those systems with the help of some filters also. Next is the stable and unstable. This is again quite important, because if the system is stable, then only we are going to realize those systems. If the system is unstable, that means we are unable to realize those systems. So, a system is said to be stable if the bounded input corresponding to the bounded output, means if the input is bounded and corresponding to this bounded input, output is also bounded, which is called as BIBO. So, the system is said to be stable. And if it is not following this, means we are getting, let us say, if output is going something like this, means if we are checking this, whether t approaches infinity, the signal is going in upward direction. So, this is called as basically the unstable type of signal. So, a bounded signal has an amplitude that remains finite, the value is finite, whereas in this the value is approaching towards infinite. So, this is corresponding to the stable and unstable systems. So, these are the classification of systems. Now, we are going to utilize this for the LTI. Lastly, we have the invertible and non-invertible system. This is the last classification of system. A system is said to be invertible if different input corresponding to the different output, means if distinct input we are providing and the output is also distinct, then we are getting a invertible system. Otherwise, the system is said to be non-invertible. Also, we can say that a system is invertible, right, if an inverse system exists which when cascaded with the previous system gives the output same as that of the input of the first system. Means at this particular end, if we are getting a signal same as xn, then also we are naming these type of systems as invertible and non-invertible. We are calling this system as invertible systems. So, these are all the classification of systems. Now, from these all classification, we will take the linearity, linear, time invariant, stable systems. We will take these classification out, and we will be seeing in our next lectures about how we can check the linearity and the time invariancy of the system. These are the references. Thank you.